So, good afternoon, everybody. I hope everybody can hear me, and hope these slides are going to work. So, I have approximately 10 minutes to describe to you some of the privacy challenges and some of the things that we've been doing in FI-ware to address those challenges and some of the lessons that we've learned. So, I'm going to jump straight into this with a short reminder of why we need privacy, why it's important. I want to get across that in privacy, there are two parts to the discussion. There is a policy part and there is a technology part. And I really want to emphasize that unless we have the appropriate technologies to be able to choose who gets access to what data, then it's a very difficult policy discussion. But it's the technology part that we've been looking at in FI-ware. I'm going to use driving licenses as a context to talk about privacy. Why driving licenses? My background is in passports and driving license technology. And it's, I think, an interesting case study. So you may or may not be aware that last year the EU regulation on driving licenses was changed, updated, to allow a chip on the license and thus the capability to introduce electronic driving licenses. The decision at the time was to use the same technology as passports to secure that information. And I'm going to highlight some of the challenges that's actually brought about. So, and why driving licenses? Actually, because there's a lot of attributes on driving licenses. I'm going to talk about attributes. Now, the primary goal of a driving license is not actually to identify yourselves with. It's actually all about road safety, to make sure that only those people who are suitable to drive cars on the road actually do so. So they're not endangering themselves or other people. So if you look at a driving license, there's a picture on there. There are identifying attributes, but there are also other data on there that you may or may not be aware of. So how do we actually secure road safety? So it's about making sure people are trained. So you pass tests to be able to drive certain categories of car. But there's another dimension. We need to make sure that only people drive suitable cars for and only drive cars in suitable circumstances or instances. So what does that actually mean? So suitable vehicles. I mean, if you happen to have a disability, if you happen to have if you've lost an arm or something like this, then it's absolutely fine for you to drive a car, but you need to have a car which is suitably modified. This is an excerpt from the EU legislation about categories. So these are little numbers on the back of the driving license which add additional information to what you are and are not allowed to drive. If we look at If we look at suitable circumstances, so for some people it's actually pretty dangerous if they can't see very well at night. You have to kind of restrict them to driving during the day. Now, those last two slides, as you can see, it's full of very sensitive personal health information. And what's the challenge with all this sensitive personal information is that there's a whole set of EU regulations on how we deal with that information. Now, if you're a police officer at the side of the road, you need access to all of that information to make sure that somebody is driving according to law, according to road safety laws. However, we know driving licenses are used in a lot of third-party use cases. They're used for identity. They're used to prove age in a bar. And in these instances, you don't want to be giving up all this personal information for these third-party use cases. So there is a difference in how these are used. There's a difference in the context to passports. And now we have the situation that all of this very sensitive data is mixed in with all the biographical data for identification on electronic driving licenses. That's why we need technologies. We need different technologies. I want to introduce the concept of attribute credentials. These, basically an attribute is an individual element of information. So it's your age, it's your gender, etc., etc., etc. And the whole concept of attribute credentials is that you're able to give up pieces of information selectively. You don't give up the whole bunch, you don't give up the whole credentials containing all of these information. Thus, it gives you the choice to be able to use the right credential or the right attribute in the right context. The other nice thing about these credentials is that you can do what are called predicates over them. You can ask, just tell me or just prove to me that you're over 18 or over 65, rather than actually giving out your date of birth. And attributes can be combined, so you can have attributes from a driving license, attributes from a credit card, which actually enables you to prove that you're over 18, that you are able to drive a certain category of car, and have a valid credit card, for example, without providing all of the information on all of those credentials. Attribute credentials have got a long legacy in Europe. They've been, let's say, developed over the last 10 years through a number of programs. The most recent of which is the FI-ware, which now I'm going to dive into a little bit. So I'm actually representing here the FI-ware security chapter. And the idea of the FI-ware security chapter is we provide a set of standard interfaces, generic enablers, that help people with a whole set of private security-related issues. So on the user side, we have like identity management generic enablers. On the IoT side, there are generic enablers for security. There are basic ones for the underlying platforms, and there are ones to protect individual pieces of data. So how do you deal with all this data? How do you actually make it easy for people to consume privacy technology? Now, one of the challenges with privacy technology, it's always been very complicated. It's all about very advanced cryptographic protocols. Traditionally, these have been provided as some sort of library. Traditionally, there's been some sort of smart card involved. And smart card and libraries, that's a little bit old world. That doesn't work in the new era of mobile platforms and cloud. So the primary focus of our work within FI-ware is making this technology available in the cloud, making it available on mobile platforms such that you didn't have to try and install smart cards and things like this. So really, this has been a really interesting part of this whole experience is FI-ware has really enabled us to provide this technology such that it's easily consumable. We've just created a demonstration online. I think this is that combines various of these generic enablers. So the privacy generic enabler, the identity management generic enabler, and the access control generic enabler to demonstrate this technology. So the scenario is kind of a Dropbox scenario where you can use certain attributes in order to be able to access certain files. So if I go back here, the attributes you can imagine, it's three companies, so IBM, SAP, and NSN have been working on this demo, and we're German, French, and Swiss companies. So just imagine that you can actually reduce a set, let's say, constrain the availability of certain files based on your nationality, or whether you're male or female, or whether you work for one of those companies. So instead of sending a whole certificate with all of your attributes in, you can actually just prove that you work for SAP or that you work for IBM. So this is what we mean by attribute-based access control. This is just a very brief high-level architecture. It's a kind of, what I want to emphasize here, this is really the first cloud-based, FI-ware-based instantiation of this technology. Like I said, most of the tests of this technology has been available purely on a big client installation with smart cards. We basically have moved this smart card into the cloud, so to speak. So you keep your credentials, your privacy-enhanced credentials, in the cloud or in the FI-ware platform and not on your user device. This means that you can actually use this technology from your mobile environment, your home environment, etc., etc. And it really removes, I'm going to skip over the next two. I've got a minute left. It really removes the need to have some heavy installation, so install a lot of software on your client. And if you think about how smart cards are used today, I mean, a lot of European countries have smart card-based national identity documents. But the major problem has been rolling out the infrastructure to actually use these documents. So it's always been a challenge. You have this nice, secure identity card, but how do you actually use it? You're not going to use it on an iPhone because they don't support smart cards. But actually, we want to make this technology available on these platforms. So it's been difficult, and actually within the FIware platform, I think it's been really good because this technology is available at the end of a RESTful API along the lines of the whole FIware strategy and thoughts. And what's also really nice, it makes it very easy to consume. So it's very easy to use these applications without having to go into very complex cryptographic integration, etc., etc. And these things must be simple, otherwise people are not going to use them. So that's my final lesson of the day. Thank you.
Introduction. I'm one of the research directors, scientific directors at the DFKI. DFKI is also involved in the Center for IT Security, Privacy and Accountability, the CISPA, also located in Saarbrücken, and some of the particularly the security-related aspects have been done in that context. I myself work both in FI content, where we started originally, and then, as I'll explain, some of the technology actually moved down to the generic platform of FI content. So let me first start from the point of view of use case projects. And I've picked a couple of aspects here. There, you can obviously add much more to that. So for instance, in manufacturing, from a security and privacy point of view, you need a lot of flexibility. And traditionally, factories have been enclosed by either using proprietary networks, or have been kind of walled off the internet through firewalls and similar technology. But that becomes obsolete and actually prohibits us to go forward, because we need to kind of drill holes into these firewalls for maintenance work and a lot of other tasks that need to be done in an open future factory. On the health side, obviously privacy is a key issue, a big issue here. We definitely need new data protection in this area, but we need a lot of flexibility. If you think there is a patient, you need to urgently act on him, you cannot postpone this because of some security issues in this context. So, someone of the patient, of the carer, can be ill or whatever. I mean, you need to quickly change personnel, but they need access, but you don't want other people to have access to the data. So it's quite challenging in this area, and also in the content where I come from with FI content. Obviously, there's very strict media access rules with video and audio. We know a lot of that. A lot of things are changing also, in particular over the last couple of years. But also it's extending. If you think about particular interactive 3D content, or now the printing, the physical printing, 3D printing, right? It used to be of IP rights on music. Now it's IP rights on physical objects, or the ability to print physical objects. And or another aspect in this context is actually streaming. Streaming was limited to video, audio streaming, but we're actually streaming 3D objects together with that, actually in combinations. And a lot of the rules that apply in some of the traditional areas don't easily go forward into the more flexible realm that we're addressing in the future internet content area. We in FI content identified a lot of these issues early on, and we posted a couple of challenges, which then were through the architecture board, where I'm a member of the FI-PPP architecture board. We posted these challenges. They became generic and are being addressed now within FIware. So challenges are, we have very fast-paced development. Requirements keep changing all of the time, both on the society side and the technology side. We have lots of advanced functionality, but it's typically provided in very low-level functional units. And then the application developer is left over to kind of build a secure application on top of that. And that's really, really hard to do, because this is a complex topic, and those developers are typically not experts. And so, in particular, for different aspects, you typically also have different middlewares for REST, for streaming, and so on. And each one has a completely different notion about security. And so we're addressing this as part of the FiWare Work Package 13, the advanced middleware part. The idea is to kind of centralize a lot of the security and privacy handling into a single middleware that can be upgraded and improved separately from the application logic, which is a big important topic. Then the application doesn't specify how to implement security, but it simply specified what kind of security it wants, what data needs to protect it against what risks. And then it's the middleware's job to automatically enforce those requirements that have been specified by the developer, and that's obviously much easier. And also you can incrementally upgrade, right? If new technology becomes available, or if new threads become are there, then you can upgrade the middleware independently of the application. Chiara, the middleware, actually has a lot of other very interesting properties, including supporting multiple communication mechanisms. It supports multiple transport levels, transport mechanisms. It supports multiple protocols in each one of them, and is designed for high performance as well, transferring data directly from the memory of one application into the memory of another application, which is not typically done what middleware actually does. Just to give you a very quick idea of how of the design behind Chiara and why that matters for what we're discussing here, Chiara very strictly separates what data needs to be transferred. This is defined by a so-called interface definition language, or IDL. And it separates that from how the data is accessed, or where the data is stored in the application. So the application tells the middleware, here's my own data structures. That's available for transferring somewhere else. And then there's a third component, which is how the data gets actually transferred. So that's the transport part. And so if you put this together, if you have two applications talking to each other, right, a client and a server, the client requests an interface talking to a service, a certain interface of a service on the other side. Both have their native data structures on the far end of the slide here. And then they agree on a common protocol, which might depend on certain restrictions that the applications impose on this, but also like what network connections actually are available. And once that is known, Chiara actually comes up with the best possible code. It also has an embedded compiler to come up with the best and fastest possible way to communicate the data specified by the IDL, given what the source data is and the target data is, and given what has been agreed on a transport level. And the really interesting part, and that brings me back to the security and privacy part, is that we can additionally to specify what I just told you, we can also specify security and privacy policies on various of these levels here, various of these points. So at the IDL level, we can say that certain data needs to be protected, secured, or there's certainly anonymization needs to happen on certain amounts of data. And all of this information, this declaration about what are the requirements by the developer, are being taken into account when generating the code that actually transfers the data. So if you then take this, right, you have services that want to talk to each other, right? One offers services, the other wants a certain service. The users declare the specifications in terms of security and privacy, and then Chiara fills in the part in between and makes sure that these service requirements actually are security and privacy requirements actually hold. And we can. This in between depends a lot on the technology. We can have a service talk to another service that is within the same application. It can be in a different thread. It can be in a plugin. It can be on the same machine but in a different address space in a different application. Or it can be somewhere else across the internet, and we actually need to talk about the network. In each of those cases, we need to generate slightly different code to fulfill the security privacy requirements, but also transport the data in a really fast way. So in terms of the security policies, the key part here is that each of the two sides of the two services have requirements and provide certain guarantees. And these are checked mutually to each other. And the two services only talk to each other when that is actually fulfilled. One of the key aspects that I want to point out here is that we also support transitive security and privacy models. So this is essentially that you can require the partner that you talk to implement itself certain requirements. So you can, for instance, tell, I will give you this data, but only if you yourself treat that data under certain conditions. For instance, you only forward it to a certain group of people. And that allows you to actually have some sort of a virtual private network, not on a network level, but actually on the interface or on the data level. And so this gives you a lot of flexibility, a lot of new features that are available at a very easy way for the developer because they don't need to deal with the low-level implementation issues of security and privacy, which should really be done by a security and privacy expert, development person who has expert knowledge in this area. There would be involved in implementing the middleware, and then the middleware provides a standard interface to the application, and so the application developer just has to specify what it wants, what he or she wants from the in terms of privacy and security. And so this becomes, and an important part in this context is that the middleware can be upgraded independently of the application logic, which is a big issue, for instance, in the manufacturing industry, where a certain machine in the factory floor might be around for 20 years, and they are scared of changing the application, but they obviously need to, on a very low, frequent terms, need to update for security, new security issues or improved security technology that becomes available. And so Chiara is becoming available now as part of FiWare. We joined FiWare rather late so that the first version is becoming, the preview is available now and the first full version will become available this summer. And we'll keep improving this through the follow-up project FI Core. Thank you very much.
Okay, thank you very much, Philipp. Thank you.